Hello everyone, today I'm going to explain different mathematical operations in assembly. Let's start with addition. So here's an example how you add two numbers in 8-bit source. So I got two registers, AL and BL. So I assign the value of 25 to AL, and move BL means assigning the value of 15 to BL, and I'm adding both numbers at the last. And here you can see my resultant over here is 40. Adding two numbers in a 16-bit source. So for 16 bits, our registers are AX and BX, and as you can see, I added these two numbers at the third command, AX and BX, and my result comes to 256. Another example, adding two numbers in a 32-bit source. So for 32 bits, our registers are EAX, EBX, and at the third command, as you can see, I add EAX and BAX, and my resultants come to 65536, which when you add these two numbers. And how do we do multiplication in assembly? Alright, so in assembly, in 8-bit source, our multiplicand is called AL register, and a multiplier is an 8-bit source, and a product is AX register, which comes as in 16-bit source. So the multiplicand is the AL register, and the multiplier is a byte in the memory or in another register. The product is AX. High order 8 bits of the product is stored in AH, which is higher side is the left side, and the lower order 8 bits are stored in AL, which is the right side. So when AL times 8-bit source equals AH AL. And here's an example. Move AL2 and move BL3 and then multiply BL. So 2 times 3 is 6, which is over here in our 16-bit source. Another scenario explaining 16-bit. Alright, so the multiplicand should be in the AX register, and the multiplier is a word in a memory or another register that you know. For example, we say that multiply dx. You must store the multiplier in dx and the multiplicand in ax. The resultant product is a double word, which will need two registers. Obviously this is another okay, so the higher order portion gets stored in dx, and the lower order portion gets stored in AX. So AX times 16-bit source equals DX AX. And here's the example. Move AL20, move DX 256, multiply DX, and the resultant is over here, 5120. Multiplication in 32-bit. So in 32-bit, our multiplicand is DXAX, our multiplier is a 32-bit size, and our product is EDX EAX, which is 64-bit. When two double word values are multiplied, multiplicand should be in EAX, and the multiplier is a double word value stored in memory or in another register. The product generated is stored in EDX EAX registers, that is the higher order 32 bits get stored in the EDX register, and the low order 32 bits are stored in the EAX register, as you can see over here. EAX times 32-bit store equal EDX and EAX. So how do we do division in assembly? Alright, so in 8-bit. In 8-bit, our dividend register is known as AX. A divisor is obviously an 8-bit size, and quotient is stored in AL register, and remainder is stored in AH register. So dividend, so here you can see that when you divide AX to a 8-bit divisor, so a 16-bit dividend divided by 8-bit divisor equals AL, which is our question, and AH, which is our remainder. So here you can see your example. So 81 divided by 2, and that's how our command works. Also move AL 81, assign this value to AX, and then move BL2, assign this value to 2, and then divide BL, so 81 divided by 2, and our resultant comes right here. This is our remainder, AH is our remainder, and our question is 40. And AX is our dividend, which is 296. Here you go. Another scenario explaining 16-bit. So in 16-bit, our dividend registers are known as DXAX. Divisor is a 16-bit size, question is AX, and remainder is DX. And you can see when you divide 32-bit dividend, so DX times AX, or which is our dividend over right here, divided by a 16-bit divisor, you get the answer AX is the question and DX is the remainder. Here's an example explaining that. So move DX0, and so which means that our remainder is 0. Move AX256 means our dividend is 256, and we're dividing our dividend, which is our by 5, which is our BX, which is our divisor. So at the last, you did the command for divide, and here's your results. So AX is your question, and DX is your remainder, and here you can see. How do we divide two numbers in a 32-bit source? All right, so the dividend is assumed to be 64-bit long, and in EDX AX register, the higher order stores in the left side and the lower order stores in the right side. And after division, the 32-bit question goes to EAX register and the 32-bit remainder goes to EDX register, as you can see. I hope I was able to explain everything, and if you have any question, please leave comments. Thanks a lot.